Hi, everyone. Thank you so much for being here today. And thank you to ColdFront Conf for having me here today. My name is Shirley, and I'm an independent creator of data visualizations. I like to use data to tell stories, both serious and meaningful, and light and fun. And once in a while, I like to use data to create art. And today, I was asked to talk to you about the future of data visualization, which, as one person, I feel really uncomfortable claiming and predicting the future of a whole industry. So instead, today, I want to talk to you about the future of data visualization that I'm hoping for. For the past year and a half or so, there would be people that come up to me after my talks and tell me that they really enjoyed the visualizations that they saw, that I shared with them, that they wanted to create them too, but that they were also really kind of intimidated by D3, the JavaScript library that we quite often use to create these visualizations. And there have also been a few people that have come up to me and told me that even though they feel quite comfortable with D3, they weren't quite sure how to take the next step. How do they go from common D3 charts to going and designing and creating their own custom visualizations? And these conversations have made me realize that not only that D3 and data visualizations are still quite a niche in the front-end communities, but also that there are more and more front-end developers that are interested in getting into D3 and getting into data visualizations. So today, I'm hoping to show you that getting into the D3 and getting into data visualizations doesn't have to be hard or intimidating and can be really, really, really fun instead. So let's get started. So to start, I want to start with D3. And I think there's two main reasons why we might find D3 intimidating. The first is the enter, update, exit pattern, which is what we most frequently come across when we're trying to learn D3. And two is just the sheer size of the D3 API. The enter, update, exit pattern is D3's way of re-rendering the DOM from an initial state, a state A, to the next state. We can call it state B. And to do this, we as the developers have to go in and manage and remove the elements, the DOM elements that used to exist in state A that don't exist in state B anymore. We call this the exit selection. And we have to go in and add the DOM elements that didn't exist in A and now exist in B, the enter selection. And we also have to manage updates to the DOM elements that were in A and remain in B, the update selection. And as you can probably imagine, having to manage all of these updates can get really confusing with more complex visualizations. But you might have also noticed that this pattern sounds quite familiar. And you might recognize this as the way React's virtual DOM works underneath the hood, which means that it'd be a lot easier if, instead of using D3's enter, update, exit pattern, we consider using React's render function instead to do the heavy lifting, to do the work of updating and managing the DOM for us. The second thing that might be intimidating is just the sheer size of that API. If you've ever gone in and looked at D3's website and scrolled through the documentation, there's a lot of modules and a lot of functionality in there. This is my attempt at organizing almost all of the modules in D3 into categories that I might into the order that I might use them when I'm creating my visualizations. And out of all of these modules, these are the ones that I use the most frequently when I'm working. These are modules like scales that help me translate raw data into screen space, into XY positions, into width, height, into angle and radii and color. These are the force and hierarchy modules that help me calculate XY positions for network diagrams, for trees and tree maps and circle packs. There's a geo module that helps me translate latitudes and longitudes into XY positions so that I can draw states and counties and countries. And there's the chords and shapes modules that help me generate from my raw data SVG and canvas path commands that I can then use to go and draw area charts, pie charts, line charts. And D3 also comes with modules for brushing to filter, behaviors like drag and zoom and pan, interactions that are really common when we're building visualizations. And it's these modules that, to me, make the unique selling, that make D3's unique selling points that I think D3 does better than any other library out there. So for an easier time, use D3's scales, shapes, layouts to translate your raw data into screen space. And use React's render function to do the actual drawing of that translated data, and for managing and updating to the DOM. But just having D3 isn't quite enough to create good visualizations for the web. D3 is a really great tool for coding visualizations in the web, but there's a whole process beforehand of analyzing the data, of designing visuals that work well with that data. And I've been trying to figure out a good process, a loose set of guidelines. For the past year or so, I've been thinking and I've been researching and trying to figure out a loose set of guidelines that I can use and apply to each new visualization project. And I want to share that process with you today by going through this data set of the top 10 blockbuster movies of every year for the last 2 decades, and building this custom visualization with you. To start, the very first thing I do whenever I've gone and gotten my data and cleaned it is I list out all of the data attributes, and I label them by the data type, by their data type, whether it's categorical or quantitative or temporal or spatial, and I mark the ones that I find interesting. So for our movies data set, these are all of our attributes, and I bolded the ones I think might be interesting. And these attributes include categorical ones like genre and director and writers and actors. There are quantitative ones like metascores out of 100, number of IMDb votes, box office figures. And temporal ones like the date that the movie was released and the date that, again, the DVD was released. And once we've listed out these attributes and marked the ones that are interesting, we can start formulating, we can look at the ones we found interesting and start formulating questions to explore the data with. And for this, I want to concentrate on just these attributes of released, metascore, and box office. And looking at just these 3 attributes, we can start kind of formulating questions, curiosities. The first might be that, when are most of these blockbuster movies released? Are they released in the summer, during Thanksgiving or Christmas holidays? And 2, what is the distribution of these metascores? Do these blockbuster movies tend to score higher out of 100? And 3, is there a correlation, a relationship between the metascores and box office figures? Do the movies that do well in the box office also tend to have higher metascores? And once we have these curiosities, we can then take these questions and use them to explore our data. And to do so, I would highly encourage you putting that data onto the screen as soon as possible, whether that's with Python's matplotlib, or R's ggplot, or Tableau, or Vega Lite, or D3, or any other charting library. I would encourage you to get them onto the screen so that you can see the shape of that data or see patterns and insights as soon as possible. For the movies data, I plugged them in to a bar chart, which is really good for seeing categorical distributions, to answer the question of when are most blockbusters released. And indeed, we can see that blockbuster movies are highly seasonal, and that they peak in the summer months between May and July, and again in November and December in the holidays. I used a histogram, which is really great for quantitative distributions, to answer the question of what is the distribution of these movies' metascores. Do they tend to be higher out of 100? And it turns out, no, they don't. Actually, most of the movies' metascores, they score between 40 and 80 out of 100. And finally, I used a scatter plot, which is really good for seeing correlation between two attributes, to answer the question of, do the movies that do well in the box office also tend to have higher metascores? And the answer here is, again, no. The dots go up and down, and there seems to be not very much of a clear correlation. But it's really great to have seen these answers, because now, with these answers in mind, with these findings in mind, I can go and create a message that I can then communicate and design my visualizations around. That blockbuster movies are highly seasonal, and that the highest box office figures tend to be recorded during the holidays. And now that we have a message to design around, I want to translate that message into visuals on the screen. And to do this, the concept that I find most helpful is the concept of marks and channels. And the way that I think of them is that I map individual or aggregate data elements to marks, and I map data attributes to channels. And I define marks. These marks are defined as these geometric shapes, like points and lines and areas. And for channels, I like to map my quantitative attributes, my quantitative data attributes, into positions like x, y positions, or sizes like width, height, radius, color scales like sequential and diverging color scales, and my categorical attributes to channels like shapes and discrete colors. And so this is my final kind of like chicken scratch design mock for our movies visual data set. And I have down here a histogram, two histograms showing the distribution of the box office figures and metascores. But more importantly, they're there so that we can have an interaction of brushing over to filter these movies down by box office and metascore. But today I want us to concentrate on this part up here, the custom part. And this custom part of the visualization is marked by, these marks are these kind of curvy things, curvy areas, and each of these curves represent a movie. And for the channels, I've assigned the data attributes of release date to X position along the axis, and I've assigned box office figures to the Y position, with a slight twist that any movie with a box office figure above the median will rise up, and any movies with a box office figure below the median will droop down. And I've assigned metascore to color. And finally, I have these markings up top that denote the summer and winter months, so that we can see if there are any peaks, any movies that peak in these holiday months. And now that we have the design, I want to turn that design into code together with you. And for the sake of time, I've already created the histograms. So I want us to go and code the custom part together. And to break this custom part down, each movie is denoted by this little curve. And that curve can be generated by a D3 area generator. And the way that D3 area works is that you can pass it a series of points. And then D3 area will go and draw a line between those points and fill in the area underneath. So to draw our little curves for each of our movies, we want to pass the area generator 3 points, the first being in the middle point being with the X being the release date of the movie, and the Y being the difference between the box office figure and the median. And then 2 points on the side, plus minus 2 months from the release dates, and the Y being the median box office. So let's do this together. I'm gonna live code this right now. Please wish me luck and that the bugs aren't too bad. So here's my code in React, and here's my app.js. This is pretty good. So just to make sure the back can see this OK? Yeah? Cool. And don't worry about following every single piece of the code, because I have this online, and I'll tweet it out later. But here's app.js, and all I do is I go and load my movies data set, and then go and I create an area chart and the 2 histograms. So let's go into the area chart, and I'm going to calculate the data with D3 and get derived state from props. This may or may not be the correct place to calculate the data for you, but for the sake of this demo, I'm going to do it in here because it's a lot faster. It's a lot easier. So the first thing I want to do is I want to go and figure out the median box office. And I use d3.median, pass in my movies data set, and tell it to calculate the median based on the box office. And once I have that, I want to calculate the X scale. And remember, scales are used for translating raw data into screen space. So in this case, I want to use the release dates of the movies. So I'm going to go and grab the minimum and maximum dates of the movies, tell it that I want to use the date, and then I'm going to create an X scale, and that scale is going to be scale time because my domain is time-based, and then I'm going to tell D3 that I want to map my minimum date, but then I'm going to offset it by the minimum date and minus 2 months, and the maximum date plus 2 months. And I want to map the minimum date to my left-hand side. I have a margin left, and then the maximum date to my whole width minus the margin dot right, and I have these defined up top. Once I have the X scale, then I want to create a Y scale. And the Y scale, I'm translating from box office figures to the Y-axis. So what I want to do is go and get the minimum and maximum box office figure. But this time, with the box office figure subtracting the median box figure, create a Y scale, d3.scale linear, pass in the domain, that's the minimum and maximum box office, and the range, which I want to map the minimum box office figure to the bottom of my visualization. So that's going to be the height that I've defined minus the margin that I've defined bottom. And I want to map the maximum box office figure to the top of the visualization, so that's just margin.top. And then I want to go and create a color scale. And that color scale is mapping from the Metascore out of 100. So I'm going to go and get the minimum and maximum of the Metascore and create a color scale using this sequential scale and passing in this thing, a color scale called interpolate verdis. and setting this domain of score min and max. I create an area generator that I mentioned earlier. And then all I have to do is call it area. And then I want to tell it the baseline for the area, the curves, so that it knows where to fill until. And that one, I'm going to use the median box office figure. And now, if I've done everything correctly, I should be ready to go and create the data for each of the little arcs, the little areas. And to do that, what I want to do is, for each single movie, I'm going to first sort them by the absolute of the difference between their box office minus median box. And that's just so that the highest peaks and the lowest dips can be at the very back, and everything else will stack on top so that you can see all of the curves. And for each single movie, what I want to do is go and generate the path command for SVG to draw the curve. And I'm going to just use the area generator that I defined earlier. And the 3 points, the first point being the middle. So for that one, I'm just going to pass the release date of the movie to the X scale, and the box office figure minus the median box office to the Y scale. And then the 2 points before and after, and that would be offsetting the release date by minus 2 months, passing that into the X scale, and then also the Y scale, and the Y being the Y scale, the median box, the line of the median box office. So there's the path, and I want to also tell it a color to fill with. So I'm going to use the color scale I defined earlier, pass in the score, return arcs as state. And if I've done all of this correctly, then once I console log the arcs and render, I should hopefully see it console log correctly. Yes, okay. So, thank you. Wait, but just, and then we have to make sure that they are actually correct. Yes, there we go. So here is the path command to draw the little curves right here. D3 generated that for us, and here's the fill. And now all I have to do is go in, and for each of the arcs, create a path element, an SVG path element, and tell it that the path command I want is the d.path that we just defined. The fill is the d.fill, and that I want to give it a stroke of white so that we can see it on top of each other, and hopefully something shows up. Nope. Line, sorry, what? 59, thank you. 59. 59. Oh, thank you so much. You're awesome. Yes, thank you for that debugging. Thank you. And now that we have this, you might notice that they're really spiky, and spiky is kind of like scary and mean. So we're going to turn them into curves. And I want to show you how easy it is to do that with just D3. And so we can go back to the area generator that we just created, and then we just tell it that we want to use a curve, and there's some built-in curve little interpolator things in D3, and I'm going to use one called curve catmull rom. And with just this one line, they turn into nice little curves that are very nice. But now that we have these curves and we know that each of these are movies, the reader needs to have axes so that you can tell what the x-axes are and the y-axes are. So I want to show you how to do that. And to do that, I have these little group elements, SVG group elements, defined down here. And I have these axes, D3 axes, defined up here, instantiated up here. And now, all I have to do is I have to return the x scale and the y scale I created earlier as part of state. And then I set those scales on the axes, use D3 to select those group elements, call the x-axis that we instantiated with D3, and that's it. I don't know if you can see it, but those are the years right there. And that's all it took, those few lines. And let me just do them really quickly again for the y-axis. And I'm just going to replace this with y-axis and this with y-scale. And that's it. That's all. Thank you. And now we have these curves and these movies. Consider putting some interactions in there. I have these interactions for showing details of the movies on hover. And I also have this interaction where if we brush over the histograms, it will then filter the movies by those box office figures and those metascores. And that looks like some fancy, kind of like nice, sophisticated interactions that might look like it's kind of complicated to do, but it's not. And I want to show you how to do them. So let's go back to our code. So here, what I need is I have this function called update filters, and I pass them down to histogram. And in histogram, it's very similar. I have some D3 functions to calculate the data. And in render, I'm just rendering the bars as rectangles. And I have this group element defined down below called brush. And in component mount, I instantiate a D3 brush. And all I have to do is use D3 to select the brush group element, call this dot brush, and with just that one line, I instantaneously get this interaction. D3 goes and creates this kind of brushable area with this little like gray rectangle that's draggable with these interactions. But you might notice that we don't filter yet, and we have to go and do that ourselves. So let's go and do that. The other thing D3 does for us is really nice, is it gives us hooks on when the brush is moving and when the brush stops moving. And so I've gone into these hooks, and on brush end, what I want to do is go and get the bounds, the right and left bounds of the little gray box. And to do that, I'm going to just say let bounds is equal to null, and if d3.event.selection, so this is how D3 goes and tells us what the bounds are. And I'm going to go and grab the x positions of the left and right from this D3.event selection. And all I have to do is say that the bounds I want is x scale invert. And what invert does is it translates from range back into domain. And so in this case, once I pass in x position, it will give me back either the metascore or the box office figure. And so I can just say .invert x1, state.xscale.invert x2. Go and pass this up to the update filters that we define in app.js. And I want to tell it whether it's box office or metascore, and the bounds that we just calculated. And if we've done that correctly, then here, I should be able to console log the filter and hopefully be able to see that, for example, when we do this here, it's undefined. OK. This dot props to attributes. Did I not call it attributes? Adder, just adder. OK, and now I should just be able to drag this and be able to see that score is we want to filter between a metascore of 50 and 60. And if I do this here, then it's going to say a box office figure of between 285 million and 700 million. Now, let's go and figure out, first of all, let's go and update our state with that. And then let's go and figure out which movies should be kept based on those filters. And to do that, we want to go through every single movie. And then for each of those movies, I want to see whether it fits within every single one of those filters. So go through the filters, and I want to get the bounds and what attribute that filter is. And I want to make sure that the movies are kept only if there's no bounds set, or if that movie falls within the bounds. And if I've done this correctly, then if I filter, or if I console log the filtered, the original data set has 98 movies, and if we've done this correctly, which I see that we have not, oh, no, we're fine. OK, then hopefully if I do this, we'll see less. We don't see less. Oh, no. Oh, no. OK. This dot state dot filter. Less than and bigger than? Right? No, thank you, though. D attribute is, oh, no, OK. OK, let's see. Let's do this again. Sorry? New object created. But, but shouldn't I be able to, let me rewrite this and try again. Dot filtered, oh, filter this by all of the movies. And then for each of them, every filters, actually, let me go and make sure that my filters are correct, like I think you were suggesting. And yes, they're correct. Cool, OK, so they're behaving as expected. So let me try it again. Filter each of the movies, and for each one of them, I want to get the bounds and the attribute, and only keep them if there's no bounds, or if 0 D attribute and the attribute is less than the upper bound. OK, please wish me luck this next time. Oh, no. It shouldn't matter yet, but I'll set them still. Filters, filtered. This.state.movies, thank you so much. Thank you so much. You are amazing. You might have noticed that I've been starting to use Vue, and I'm like now confusing the syntax between them. Thank you so much. Oh, you've just saved me. OK, now, OK, now you'll see that when we filter, now it's like 57 movies. Or if I filter again, it is 46 movies. So this is now going correctly. And the last thing we have to do to make sure that it's being filtered correctly is in the area chart, instead of using the movies data set to create the arcs, let's use the filtered data set. And in the histograms, instead of using the movies data set to create the bins for each histogram, let's use the filtered data set. And if I've done this correctly, there you go. Ooh, yay! Thank you. OK, there we go. Thank you. Thank you for saving me just then. And finally, add some titles and descriptions and axes and legends and annotations to ensure readability for the users and guide them through how your visualization works. And this is the final version of the visualization. And you can see that indeed the highest peak is in the winter. And this one in particular was Star Wars. And it had a box office figure of almost $1 billion. And the second highest is Avatar, and this was also in December with $850 million. And I can also, this is the fun part, I can also go and be like, I wonder which movie scored more than 80 but didn't do so well, did below the median for box office figures, and they're The Martian, Inside Out, and the Lego Movie. And conversely, let's go and look at movies that did kind of horribly, but still did well in the box office. And, oh wait, no, still did well in the box office, and that is Transformers. Transformers again. And the Twilight Saga. Thank you for humoring me on this one. Thank you. So the future that I'm hoping for, the future of data visualization that I'm hoping for, is that with React, D3 becomes easier to get into, and that front-end developers will adopt D3, and it will no longer be a niche. And that there will be more and more good, thoughtful visualizations, and they become more commonplace in the web. And I've kind of crammed all of these hopes into a series of workshops for front-end masters. So if you're interested in them, they go into a lot more detail about the topics I covered today. So I hope you'll check them out, and I hope you fall in love with D3 and data visualizations. But most importantly, I hope that you'll help me in making the building of good, thoughtful visualizations a much more common occurrence in the web. Thank you.
Amazing. Amazing. Do you want to come and take a seat?
Sorry, what?
Do you want to take a seat?
Oh, actually, depending on, so I actually have a Vue version of that demo if anybody wants to see it, or if you just want to do Q&A.
We might be. Hate to say it, we might be short on time,
okay.
So I think we might just do Q&A.
Okay, sure.
I'm sorry, I'm everyone's enemy now. Everyone's. Yes. Thank you for that. Thank you.
Let me just say really quickly then that I'll post the Vue one online, and that even though I said that React and D3 is my hope for the future,
yeah.
I'm really excited about Vue because it helps me do much more with less code. And I've actually not felt that much joy in coding in a very long time.
Wow, that's a recommendation and a half. Yeah.
So for the future, the future that I'm hoping for is with Vue and D3 and GreenSock. Nice.
Shirley, do you want to take a quick
yeah,
seat?
Yeah.
We'll just chat for just a couple of minutes,
yes.
so that Vitaly will have a chance to.
Sorry, that took longer than expected.
No. I mean, I think we've gradually been running a little bit late, and that's probably my fault. I love the things I've seen in there. It's amazing. I really love seeing those kind of examples. I'm also incredibly impressed with the 450-person pair programming effort.
Thank you for the debugging. That was amazing.
There's some good input from people there. So it's great you kind of showed where we could go to see some of the work and get a little bit involved. But I'm also really curious about a little bit to do with the process. When it comes to deciding how you're going to visualize some data, how much of a clear image do you have in your mind before you start? Do you think, OK, I know how I'm going to visualize this? Or does it evolve over time based on what you're seeing as you're working?
A little bit of both.
Okay.
So it really depends on the data set. And oftentimes, I'll go into a visualization not because I found an interesting data set, but rather I have a curiosity about the world.
Right.
And so I'll go out and find a data set to kind of fulfill that curiosity.
Yeah.
And sometimes, depending on the curiosity and how well I know that curiosity, it will either come to me really quickly, the final visualization will come to me really quickly,
yeah.
or I'll spend a really really long time, like months, kind of going back and forth with the visual design until I'm like really satisfied.
Right.
I have a project that's been kind of going on for 1.5 years, and I have another project that's been going on for 3 years.
For 3 years? Anything to announce anytime soon? 3 years?
Not those two, but I do have a piece for the SF MoMA that came out recently that I'm really proud of.
Yeah.
And I have another piece coming out with The Guardian about homelessness that I'm really proud of, that I hope you'll check out once they come out.
I'm sure people will. And so you kind of mentioned like finding interesting data sets and exploring those. Have you got any, because I have a feeling that quite a few people have their kind of appetite kind of whetted now after seeing some of that. I always want to go and play with some of these things after I've seen a talk like that. Have you got any tips for anyone about where they can find interesting data sets that they can explore and then start playing with and looking at themselves?
Yeah, so if I think a little bit more political data is easier to find. Like a lot of news organizations will have them like data sets curated. So like 538, I know in America, so 538 is a news organization that curates a lot of it. I know in America, there used to be opendata.gov.
Okay.
Yeah. They're archived somewhere. So the government keeps track of a lot of data also. But I tend to, in my spare time, like looking at like more pop culture, silly, fun kind of visualizations and data. And for those, I just go out and I make them myself.
Oh, really?
Yeah, so I did a piece on Hamilton, which is this musical that I was obsessed with. And I literally went through the lyrics line by line and made the metadata myself.
Okay, well, that's not the answer I was hoping for.
But the internet has some great data sets.
Okay.
Just Google them.
Okay, yeah. I love your commitment from one end of this process right the way through to annotating the metadata in the lyrics of Hamilton at the other end of the example.
I can be very obsessive.
I suspect that's a very useful trait in some of this work. So I'd love to chat more. We'll have to chat more around the conference. Hopefully you're around a little bit. But for now, thanks ever so much for an amazing talk. Shirley Wu, everyone.
Thank you so much.
Thank you, Shirley.